Okay, so we're going to start with our K-map. Last time I always like already mentioned about K-map. What is the purpose of K-maps? And we're going to use this K-map. And I already mentioned K-map is very important. Okay, as I mentioned, that K-map is very important, especially when you have a simplification versions of question. If you want to know what is the answer for the simplification versions of your Boolean expression, you need to use K-map to prove that that is your final simplified versions of K-map of Boolean expression. Now, if you still remember, I hope that of course you're going to remember how your truth table look like. It's going to be like having the input side, and you're going to have the output. One output, of course, for all truth table, for all your Boolean circuit, and for your logic circuit and Boolean expression. So only one output. And this side is your input, this is your output. So this is how your truth table will be look like, with the input, with the output, and you're going to
Um,
yeah.
Doctor, sorry for interrupting. I think you need to accept Yusuf in, like Yusuf Khalid.
What again?
Um, I think you need to accept Yusuf in.
User in this one. What? User in. What do you mean by that?
Yeah, Yusuf,
Use F.
the name of uh,
The name of what?
Doctor, no, the Yusuf Khalid
Oh,
say
user can.
he cannot join
a
the
student,
meeting.
Oh,
Yusuf Khalid.
okay, but as I mentioned, I already mentioned several times because I already do the auto admission, and you can see here there is no
No
any,
request.
yeah, there is no request at all. So maybe they can like try to join again. Someone tell the doctor to admit me. There's nothing here. Wait, I WhatsApp. You cannot see, right, any coming uh notifications. No. See, it's auto admit supposedly. This is already here, right? Aduh. Okay, shall I continue? Okay, just now I draw already your truth table. This is your output, this is your input. And you can see uh, after you have this table, you need to convert it to K-map. Why? Because by using K-map, you're going to get the simplification versions of Boolean expression. And there is several things that you need to know and about K-maps, like the flow of the input, how you're going to draw it, how you're going to write it, and then how basically the K-map look like. Okay, so this is an example. If you have the auto admission, okay, then I guess so. This is example if you have two inputs. If you have to input, normally you're going to have like A, B, 0, 0, 0, 1, 1, 0, 1, 1. This is your normal truth table, and this is your output. Let's say you have 1, 0, 1, 0, 0, 1, 1, 0. Okay, this is your normal truth table. So how you going to represent to the CAM app? It's going to look like this. A, B. Here is the side for you to put the input. If B here is at the side, and for A here is going to be at the side. So you're going to write down the possibility input for A. A, of course, is going to have only possible 0 and 1. B also is going to have a possibility of 0 and 1. So you need to start with 0. After 0, it's going to be 1. You need to start to 0. After that, it's going to be 1. And it's going to look like a cell rather than a table. So you have 4 cells here. Why is 4 cells? Because you have 4 possibilities of your combinations if you have 2 inputs. So 4 cells. And how are you going to convert it? You look into 0, 0. Where is 0, 0? Here is 0, here is 0. Then your output will be inside here. Your output will be 0. For the case of 0, 1, 0 is A and 1 is B. B is 1, 0 is A. Then what is your output? Your output will be 1. Next case, which is 1, 0. You have 1 for A and 0 for B, and your output will be 1. Last case is 1 A and 1 B. Your output will be 0. Then this is how your CAM maps look like. This is for 2 inputs. How it, let's say you have 3 inputs. You have 2 way to draw. You can have A, B at this side and C is here. Of course, you cannot do like this. And where is this part? This is like a normal table. So you need to have at least like one input here and there is another input here. So if you have 3, of course, you're going to have like this. So for C, what is the possibilities? Only 0 and 1, isn't it? And possibilities of A, B. You're going to have 0, 0, 0, 1, 1, 0, and 1, 1, isn't it? So this is the possibilities that you need to draw here. But please see it carefully. Your stage for all the cells, you need to start with 0, 0. After that, you're going to start with 0, 1. And this is the things that you need to remember. After 0, 1, you can see here is fixed. Here is change. When you convert it from here, this one will be fixed. 1, 1. This one will be changed. If you put like this, 1, 0, both is changed. So we don't want it to happen. So for the CAM map, just stick at your mind after 0, 1, it will be 1, 1. And after that, it will be 1, 0. This is the flow for you to remember. If you put 1, 0 and 1, 1, like your table, right? It doesn't matter because your table you can like starting with 1, 1, and then it's depend on you how you're going to write at your table as long as your output here is correct. You put the output name following your input scenario. There is no testing that you need to follow the from 0 to 4, which is 0, 0, 0, 1, 1, 0, 1, 1. No, for the true table, it's okay for you to write any way for you. But if let's say in your final exam or your test, of course, it's better for you to write in flow first, to easy yourself to know, okay, is it all the input already complete, and also help your lecturer to find out that, okay, this is the correct way, and easy for us to see the output rather than sometimes it is 1 1 and then over here it is 0 0. So we need to see basically 0 0 1, where is 0 0, where is 1 1. But there is no must, which is tak wajib. It is not a must for you to do with the flow. But for CAMAP, you need to follow this flow, which is 0 0 0 1. It will be 1 1 and 1 0. Then you fill in the value inside following the scenario. Okay, that is for 3 input. If you have these 3 input, you can also have like this. A here, which is 0 and 1. You can have B, C at this side, which is, of course, you're going to have similar 0 0 0 1 and 1 1 and 1 0. You have all together at cell for CAMAPs. And the scenario here is very critical. If you didn't do this flow, your answer will be wrong. Although you said, Doctor, but basically for this table, in the case of 0 0 1 1, sorry, 0 1 1, at my output here is 1. 0 1 1. Okay, my output is 1 and I put it correct. Wait, okay, let's say you did like this. 1 1. So you said, Doctor, at this part, my output for the truth table, it is 1. So why you said this wrong? And then maybe at here 0 1 0 is 1. So I put it correctly. Why you said this wrong? So for this part, it is very important for you, not because of from you convert from the truth table to the CAMAP. No, but later you need to play around with grouping and grouping. When you are doing it wrongly, your grouping is going to be wrong, and your Boolean expression simplification version also will be wrong. So that's why at starting, please make sure you remember the flow, which is 0 0 0 1 1 1 1 0 for your care maps. Okay, for your care maps. So that is on the care map. You can read and go through why you need this care map, what is the use of this care map, and etc. And inside this care map, why you need this care map and how this care map help you in representing your Boolean expression. Okay, at this side, don't look here, okay? At this side, you're going to have input A, B, and C. And please make sure you remember P S O P, A equal to 1, A bar equal to 0, your output will be 1. While for your POS, A equal to 0, A bar equals to 1, your output will be 0. So this you need to remember in your mind. SOP is A dot something, which is A dot B, which is multiplication. POS, A plus B, which is addition. So let's take a look first for SOP, how you're going to get inside here the Boolean expression for every cell inside. So for every cell inside, we start with this one cell. Cell number 1, we have A equal to 0, B equal to 0, C equal to 0. Refer to this, we're going to get A bar, B bar, C bar. Why it is multiply? It is a SOP. Next, our second cell. I have A equal to 0, B equal to 0, C equal to 1. So my Boolean expression will be A bar, B bar, C. 1 for C. I go for the next third cell. It's going to be A equal to 0, A bar, B equal to 1, C equal to 0. My fourth cell, I have A equal to 0, B equal to 1, C equal to 1. If you still like, what is that doing here? How I'm going to get A bar, B, and C? Please make sure you refer back to our previous class yesterday. Okay, now you have
Sorry,
over,
doctor.
yeah.
How did you know that it's SOP, not POS?
Oh, I already mentioned to you. Okay, now we look into the consideration SOP first. Later, we're going to look into POS, okay?
Oh, okay.
Okay. So here, this is on the SOP thing. So we assume it to be SOP first. Then next, we have the condition of A equal to 1, B equal to 1, A, B, and C is C bar. And here, A is 1, B is 1, C is 1. And next, A is 1, B is 0, C is 0, A is 1, B is 0, C is 1. So this is our terms, product term for each cell for this part. So if let's say you get, where I going to draw? Okay, if let's say you have the similar, okay, represent here, and you have 1, 1, 1. Let's say you get like this CAB. Okay, so what is your Boolean expression from this K map? So here, you take a look here, you're going to get F equal to A bar, B bar, C bar. And this one is plus A, B, C plus another one here will be your A, B bar, C bar. So this is how you get from your K-map. Basically, it's also coming out from your two treble because you are depending on the scenario of your input. Okay, that is on SOP. How if let's say it is POS? POS, you're going to have A bar equal to 1, A equal to 0, and your output will be 0. So the one that you're going to look is at 0. Just now you can see you have take a look into 1, 1, 1, is it? Like here. So now for POS, you're going to look into the 0, 0, 0 things now. But let's take a look how, if let's say over here is our POS, how the Boolean expression. So A is 0, B is 0. Look here. A is 0, B is 0. You're going to get A plus B plus our C also 0. C. For this cell, we have A is 0 plus B is 0 plus C is 1. Why C bar? Because C bar equal to kenapa dua-dua kat sini? 1. And next cell, you're going to see A is 0 plus B is 1 plus C is 0. Over here, you have A is 0, B is 1 plus C is 1. Again, you have over here all 1 for A and B. A bar plus B bar plus our C is 0. And at this cell, all 1, 1, 1. So we will get A bar plus B bar plus C bar. And lastly, I'm too lazy to do. I think it's enough for this example. You can see if let's say you have the truth table, the care maps, like 0, 0, 0. The rest will be 1, 1, 1. So look into this 0. This one, F equal to A plus B plus C. Multiply with next. Salah. Oh, okay, here. 0 here. A plus B bar plus C bar. And last one, our 0 is here. It will be this part. It will be A bar plus B bar plus C. So thank you for your friend that asking, how do I know that it is SOP or POS? It depends on the question. If it is asked about SOP, so you need to know on the SOP terms. If it's asked you on the POS, you need to know on the POS. And of course, SOP refer to the output of 1 and POS are referring to output of 0. So any question for this part? Hello? Any question?
Clear, doctor.
Clear. Okay, thank you. Um, okay, now I'm going to continue with the example given. This one we already looked into, right? So for 4, it is also similar things. You need to refer to the input value. Where is your input? This is all your input value. Where is your output? Output will be inside. And sorry, it's you're going to look also on the case whether it is SOP or POS. If SOP is, you're going to get like this, which is A bar because A is 0, B bar because B is 0, C bar because C is 0, and D bar because D is 0. So this is the Boolean expression or product term for this specific cell. So this specific cell, there is their own product terms. Okay. So for now, I hope that you understand this part. And you need to know also on adjacent. Okay, what is adjacent in Malay? It's going to be mentioned bersebelahan. Bersebelahan. Where is your adjacent side? Okay, let's say you have 1 here. You need to know this one is your output 1. Where is your adjacent cell? You look up, you look right, you look down, you look to the left. You need to look 4 angles: up, down, right, left. So this is your adjacent. So you cannot look like 45 degree here. This is not your adjacent. Again, I repeat, your adjacent only up, right, bottom, and left. Your like 45 degree, although you can like see, oh, at the edge here, doctor, it's mid. No, it is not adjacent. Adjacent is sebelah. So mean only the sebelahan. So at the opposite like this, 45 degree, here is what degree? I forgot already. It is not also adjacent. At here, it's not adjacent. Here also not adjacent. So the one that you need to consider as the adjacent is up, down, right, and left. So in the case of this cell, if this map, care map, this is your adjacent. This is your adjacent for your right. This is your adjacent for the bottom part. And for the left, it's going to continue to here also. So this is your adjacent. You have 3. Because supposedly there is here, right? But this will be represent similar to this part. Okay, that is one thing. After that, if you have this big care map, you want to see this number 1 output adjacent. Where is the adjacent? Up, bottom, right, left. So this will be your adjacent, this will be your adjacent, this will be adjacent, this will. Why you need to know on the adjacent? Later you will need to draw a grouping. Okay, there is several rules how you're going to draw a grouping. So first, before you learn on grouping, you need to know the adjacent. Now let's take a look several other example. Okay, if you have one here, this one, the adjacent will be also at the left. So at the left, where is the adjacent? It's going to be here. At the right, where is the adjacent? Here. At upper, where is the adjacent? This one. And below will be here. So you need to know where is the adjacent following topmost. Okay, this one is how you see the adjacent. There is a topmost, there is a bottommost cell, a row and a column, a row are adjacent to each other. So here will be adjacent to here, here will be adjacent to here, but basically it's going to have 4, right? So this side will be adjacent to this one. So you need to see later on why you need to know all the adjacent. Now there is 2 cell of adjacent, the example. 4 cell, 8 cell. So why you need to have this all cell? Because the bigger the cell you have for your grouping, the simplified version you will get very high. Next. Okay. This one is the objective for you to look into the care maps, which is like the objective. How you're going to draw the care maps. Later, you will apply these all adjacent things for the grouping. Now, let's say you were given only for this Boolean expression. You know this is SOP by just looking to the Boolean expression, you know, okay, this one is SOP. Now, because of SOP, what happened? SOP. A equal to 1, A bar equal to 0, my F will be 1. Fix this one first. After that, look into all the Boolean expression. A bar equal to 0, B bar equal to 0, C bar equal to 0. And then A bar equal to 0, B bar equal to 0, C equal to 1. A equal to 1, B equal to 1, C bar equal to 0. A equal to 1, B bar equal to 0, C bar equal to 0 by like this. And you can draw the truth table at the care maps. If 0, 0, 0, 0, you still remember yesterday, right? If this standard versions of SOP meet, then you're going to get 1 for the output. Please make sure you see back because yesterday we already do the manual things and the speedy one. 0, 0, 0. 0 for A, 0 for B, 0 for C. This will be 1. Next, 0 for A, 0 for B, 1 for C. A, B, C. A1, B1, C0. A1, B0, C0. So that is your care maps, and the rest will be 0, 0, 0. This will be your SOP, and by using the similar care map, you can come out also with the POS. So I just show you how the POS look like. POS A equal to 0, A bar equal to 1. My output will be 0. So that's why I'm going to look into the 0 part. Over here, My answer will be A B bar, sorry, A plus B bar plus C. Multiply for this scenario, I'm going to get A plus B bar plus C bar. For this scenario, I'm going to get A plus B, oops, A bar is 1. Okay, plus C bar. And here I will get A bar plus B plus C bar. So this is my POS from DCAMAPS. This is my SOP from DCAMAP. So from DCAMAP, you can get the POS. You can also get your SOP. So any question? If there is no question, we're going to proceed with another example. Another example will be A bar, B bar, C bar, and I look here, this is SOP. I know, so I'm going to convert 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1. Here will be 0, 0, 0, 1, 1, 0, 1, 0. Okay, so for this, I can draw my care maps A, B, C, D. I need to remember it's going to follow the sequence 0, 0, 0, 1, and then 1, 1. And here is 1, 0. For my AB, it's also similar 0, 0, 0, 1, 1, 1, then 1, 0. And because of this, I'm going to check one by one. 0, 0, 1, 1. Here 0, 1, 0, 0. And 1, 1, 0, 1. 1, 1, 0, 0. 1, 1, 1, 1, 1. 0, 0, 0, 1. 0, 0, 0, 1. And lastly 1, 0, 1, 0. Okay, here. So the rest will be 0. So it's very simple, just a simple representation for Boolean expression. You will get your KMAP. So here, this one is on SOP. Similar things, similar methods that you can apply. Here you can see POS, A equal to 0, A bar equal to 1. My output will be 0. So, under POS, A equal to 0, B equal to 0, Y, C equal to 0. A equal to 0, B bar equal to 1, C bar equal to 1. A will be 0, B will be 0, C bar will be 1. A bar will be 1, B bar will be 1, C bar will be 1. So, depend on this scenario, I will get what? 0, not 1. So let me draw my truth table. This is another example. You can like simply mapping and using this one. So I'm not going to follow that truth table. Instead, I'm going to draw like this. So then you have the variety of choice. Both are correct. Oops, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1. Here, 1, 1. So I have 8 cell altogether. I check here. The scenario is 0, 0, 0. I put here as a 0. Why 0? This is POS again. 0, 1, 1. 0, 0, 0, 1. 0, 0, 1. And then 0, 1, 1. 0, 1, 1. And another one is 1, 1, 1. So the rest will be 1. So this is basically similar to this one. Okay, any question? If there is no question, let's proceed. Map the following expression on CAMAP. This one is also similar thing like this. But this time you have 4 variables or input. First thing I need to check, is it SOP or POS? Now I know, okay, this is POS. POS, I'm going to do A equal to 0, A bar equal to 1, and my output at my CAMAP will be 0. So let me come out first for this value of binary. Binary value for A will be 0, 0, 0, 0. And here will be 0, 1, 1, 0, 1, 0, 1, 0. Okay, I get this done. Now I'm going to draw my CAMAP. Sorry, as usual, it's going to be ugly. 0, 0, 0, 1, 1, 1, 1, 0. So I always remind you, don't do vice versa thing. CD. 0, 0, 0, 1, 1, 1, 1, 0. And at the case of 0, 0, 0, 0, where is it? Here. I put 0. 0, 1, 1, 0, 0, 1, 1, 0. It's here. And another one is 1, 0, 1, 0, 1, 0, 1, 0 is here. So there is only 3 conditions, and the rest will be 1. Okay. Easy peasy or hard? Okay, we're going to move because I want to speed up a bit. You can see over here it mentions about non-standard SOP expression. How, if let's say you are facing the problem when you were given with Boolean expression, but it is not standard. Last time you have the solution. If it is not standard, what you need to do? You're going to do the standardization. How? The standardization is for the SOP, you need to use the rules number 6. I forgot already, this one. And for POS, you need to use 2 rules. Rule number 12 and rule number 8 maybe. Please double check. But this is the standardization way for you to use and to standardize your SOP or POS. But it's sometimes going to take quite long. So why don't you just use the logic? Your logic. Okay, I give you a simple example rather than this one is quite complicated. Okay, I give you a simple example. Let's say I have A plus AB. Okay, this is my simple Boolean expression. For simple Boolean expression here, I can see, okay, I have 2 variables. From these 2 variables, of course, I know, oh, this one is not having enough B. So I lack only B. For this part, it's okay because it's already standardized. I know that 1, 1 will be 1 for my care maps. Let me draw. A, B, 0, 1, 0, 1. 1, 1 will be 1. The rest I don't know yet. It depends on my situation here, right? Because I don't know this one. So, if I show you, if let's say you are doing the standardization, you're going to multiply with B plus B bar, isn't it? So you're going to get AB plus AB bar. So from here, if you like convert it to the like standardization, you're going to have AB plus AB bar plus the rest of other Boolean expression. So at this part, you can see that A will be fixed. The only thing that changes, which is at this part, is B. So you're going to have B and B bar. So this is happen when you use your logic, you're going to fix your A here. A will be, for your SOP, A will be 1. And for your B, you can have either B or B plus, which is, there is 2 possibility for B, right? You're going to have a 2 possibility for B, which is 0 or 1. This one is fixed already. This is possibility to have B here. You don't know whether this B is 1 or this B is 0. So that's why you're going to use these two combination, which is when you have 1, 0 or 1, 1, your output also will be 1, 1. So here 1, 0, 1, 0 will be 1 and another one is similar, which is 1, 1. So this is your care map. So if it is not enough, you still do not understand, you can see over here another example. You have A bar plus AB bar plus ABC bar. This is your Boolean expression. So from here, you're going to see, okay, this one is already standard, this is not, this is not. This will be having still missing B and C. So what you need to do is A bar is equal to 0 and the value will be fixed. And the rest, which is B and C, is not yet enough here, is not here. So what you need to do, you need to do the possibilities. Ya Allah. What possibilities will having for B and C. So this is all the possibilities. That's why you combine it all together. Then you will get 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1. And for all these, you're going to get 1, 1, 1, 1 for your care maps. 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, and 1, 1, 1. That is on your A part here. For A, B bar. A, B bar, you are missing C. This will be fixed, which is 1 and 0. And for your C, your possibility will be having only 0 and 1. So you combine together, you will get 1, 0, 0, and another one is 1, 0, 1. 1, 0, 0, 1, 0, 1. So you finish with this and this. And lastly, this will be 1, 1, 0. 1, 1, 0. Where is 0, 1? I guess this part. Let me show you. Okay. At this part, 0, 1, 0, 0, 1, 1. It is here. So why it's coming here, it is for This one is A. This one is A bar. This one is A bar. This is B and C possibilities that happen because you are missing B and C. And over here, your fixed value is A and B bar. This one is A, this one is B bar. And your possibilities that you're going to add is C, which is 0 and 1 only. So without going for your standardization version, you can like directly use these logic methods and you can draw your K-maps. If your Boolean expression given is non-standard. Any question? Any question for this? This morning I have class and I give one question to the student to do this non-standard SOP expression and draw the K-map. But the student said, I rather prefer this standardization version. It's like more secure to get the answer rather than using the logic things, which is like, because maybe think that you just learn, so that's why it's like quite awkward for you. But later if you do many example, many exercise, you can directly come up with all these values and get the K-map. So any other question? If not, I'm going to proceed. Okay, you were given with this SOP expression, and of course you can see it is non-standard because you can see here is missing A and D. Here is missing C and D. Here is missing D. And this one is all okay. So there is a over here part that is missing. So maybe let me start with the drawing first. K-map. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So from here, okay, let me draw the self things that I already know the answer. This one is A, B, C, bar, D. Oh, there is another bar, I guess so. I don't know what is the correct version, but let's try to do this. A, B, C, D. Bar, bar, bar. And A, B, C, D, bar. Okay. From this, we were going to get SOP A equal to 1, A bar equal to 0. Our output will be 1. This one will be 1, 1, 0, 0. 1, 0, 0, 0. 1, 1, 1, 0. So let's take a look over here. AB is 1, 1 and CD will be 0, 0. It is here as a 1. And next, A is 1, B is 0 at this part. And my CD will be 0, 0. And another one is A, B, C is 1, 1, 1. D is 0 at this part. So I done with this. Okay, I get lah. Okay, about like roughly 1.5 mark maybe. And how about this? Let me do the simple thing first. A, B, C. This, my lecturer said, need to be fixed. A, B, C. It will be 1, 1, 1. And what that I'm missing? I'm missing D. So what is the possibilities of D? I'm going to have 0. I can also have 1. So I combine it together. I get over here.
Doctor,
Yes.
Is it a A, B, bar, C?
A, B. Oh, okay. A, B, bar, C. Okay. Thank you for correcting me. I cannot see this bar. It's like very far away. Now you can see you have over here, when you combine it together, you get 1100, 1101. So let we map it here in our map. 1100. It is similar things here. 1101 going to be here. We done at this part. Okay. Now, because we done, okay, you want to have A, B bar. What we missing? Before we look into the missing, we need to know what is the fixed number. It will be 1 and 0. And we are missing C and D. What is the possible C and D? It's going to be 0, 0, 0, 1, 1, 0, and 1, 1. This is the possibilities that happen. So we combine it together. We're going to get 1, 0, 0, 0. 1001, 1010, 1011. So check here 1000. It adds similar things here. 1001 here, 1010 here, and 1011. We done at this part. So all we already done now. We continue at the last thing, which is on our B bar, C bar. And this is the fixed thing will be 0 and 0. What is our A? A and D. The possibility will be 0, 1, 0, 1, 1, 0, 1, 1. So we combine it together, but this one, we need to be careful because our A here, our B here, our D here, we need to combine carefully. A will be 0, B will be 0, C will be 0, D will be 0. A, B, C, D. And next, 0 for A, B will be 0, C will be 0. This one is fixed, okay? And our B, our A, our D will be 1. Here will be 1, 0. And here will be 1, 1. So that's why we're going to look into this. 0, 0, 0, 0 will be 1. 0, 0, 0, 0, 1 will be 1. 1, 0, 0, 0. 1, 0, 0, 0 here. And 1, 0, 0, 1 is here. So we complete everything. The rest will be 0. So this is how you draw your care maps directly. Instead, you change it to your standard versions of your SOP. Then you take several like rules and etc. Several steps. Then just you get the standardization version. You convert to care maps. Instead of doing that long way, you can directly use this term and convert it to your care maps. This is the versions of the answer, but slightly is like quite confused. Where is the bar for? But you can try to have a screenshot for this. I can't remember. Is it our answer is correct? It's similar. Okay. Now after you have gone through how to draw it, how to convert to your care maps, you need to also take a look into this, which is care map simplification of SOP expressions by combining whatever you have learned just now. This is all combined together. Where is it? You need to group the first Then you're going to look into the product term. This product term you already learned at the page number 1, I guess, for the CAM maps. And sum the result. So let's take a look what is the meaning by this. The group must contain cell of 2 times to the... Okay, I don't want to read this because it's like very headed. Now you can see over here, if you go for your care maps, you're going to get like this output, isn't it? This look and this look. How you're going to combine and draw the grouping? What is this for? You can see over here, all there is a group, and etc. So you have to follow the rules here to group 1, 1, 1, 1, or to group 0, 0, 0, 0, POS. You need to follow this. You can group number 1, digit 1 for the output, and group digit 0 for the POS, but you need to follow whether it is having 6 inside the rectangle, or maybe it is 8, maybe it is 4, maybe it's 2, or maybe it's 1. You cannot have 3. I give you example, let's say like this. You cannot group the grouping like this. Although it is adjacent to each other, but this one there is no adjacent. There is only one you cannot. You need to have at least 2 adjacent to each other. So for this side, it is have 2, then it's okay. You can group it. But for this part, you have only 1. This one is only 1. So that's why you cannot grouping it. You cannot group this also. And if you have and check here, this one also you cannot group. Of course, because this is 6. You need to have like 16, 8, 4, what else? 2 and 1. 2 and 1. And you cannot have 3 like this, although it is already like a bigger piece. And what else? Although it's mentions that you need to have 4, you cannot have 4 like this. You can have either it is a square or it is a only rectangle. So then you can like see, you can group 4 here, or maybe you are grouping these 4. Okay, what is the purpose, doctor? Why I need to learn how to draw the care maps, how to group the care maps? So the grouping is for you to get the Boolean expression for the simplification version. If you wrongly group it, then your answer is not the simplified version. Okay, let's see what else you need to know. I think you can go through this. Let's see the example. Now, just now you already learned on adjacent, right? Which is bersebelahan. For this part, I teach you, you need to look up, you need to look down, you need to look right and left. For up, you go and then you check, oh, there is no one yang bersebelahan. There is no one for adjacent to each other. So it is no. Then you check back to the right. There is no in output 1. So it is no also. The bottom part, there is no one also. For the left part, there is no also 1. So that's why you need to circle only itself, because there is no adjacent for each other. You check this one first. After you're done with this, you check this. This, you check here, there is no adjacent. You check here, there is no adjacent. You check for the right, there is no adjacent. And bottom, Yes, it got. So because of bottom it's got, then you check this bottom, is there any adjacent beside here? Then you check, okay, there is only one adjacent. So you have 1 and 2. And including the trees, you have 3. Can you have like this? Cannot. You need to think on the square or rectangle. So you need to have like square here. Is there any one here? No. So you cannot draw like this. So you will finish until only these two. Why? Because you need to prioritize. If you have 16, you go for 16. If you go have 8, you go for 8. If no, then you go for 4. If there is no 4, then you go for 2. And if you have 2, don't have 2, then you go for 1. But if you have 2, don't go for 1 unless you don't have 2. So that's why over here you have 2 grouping with 1 and 1. So draw 2 instead of you are just drawing like this. So you're going to draw the grouping like this. And you can see this one, there is still no group. You check up, you check left, you check right, you check bottom. So when you check, double check, you can see, oh, on the right, there is one adjacent. So you're going to group it. This is how you're going to group the output of 1. Later you will see all the grouping having their own Boolean expression. Okay, next you have another example number B. You have this one, you check your right, left, upper and down. You have several possibilities. You can see at your right there is 1. At your bottom it is also having 1. So your Boolean expression or your grouping, you can have either like this or like this. But if let's guess that is 0, 0 here, then you can have either this one, this or this one. But over here, you can see that at this side, you have adjacent, then it's okay. Here also you have, then it's okay. I want to find at least 4 because this is the biggest that I can get. Here, no. So I cannot have this rectangle. I cannot have this rectangle. But when I double check again, my left side, it is similar things, which is I got over here. I check my upper side. My upper side is having 1. So there is a possibilities for me to go for this. And I check beside here, I have also 1. So that's why I can have my imaginations to have like this square. 1, 2, 3, 4. So this is the biggest square that I can draw. Instead of having like this or having like this, instead of having like this, the biggest is the priority. So you need to go for the biggest. If you can go for the biggest, you need to prioritize your biggest circle or grouping. Rather than you just circle like this, or just now I show you if you just circle like this one. You said, Rutte, it's already circle, it's already in group. So what happened? What is the problem? It's going to be a problem later on for your simplification version. You need to go for the highest and the maximum. If you can go for 8, go for 8. So if you cannot, then you go for 4 first. Then you have over here something that you can group for 4, then go for it. Next, you have here, there is still no grouping. You can see upper, side, left, and down. You can see, oh, this part you can group. You can land the things that already in group. You can group it again unless, because you need to make this with another group. So that's why it can be done like this too. And after that, this one is not yet in group. So you check left, right, and you can see bottom you got 1. So you group it. So this is the answer for your grouping also. Next, for example number C. For example number C, you can see over here, you check one by one. I have over here 1. I check my upper, there is no. My left over here, no also. My right, yes, it's got. I can have the possibility. I check my below, it's also got. So I have 3 already. Can I have 4? So I check the circle one. Oh, there is another one. I check for the square. That's why I can do this. I go for another. I can see this still not yet in group. So I check this one. I see, oh, there is a possibility for me because I got right. Upper, there is no. Below, there is no. But at the left one, I got the possibilities. I have already 1, 2, 3. Can I have 4? Then I check again. Wow, I have 4 in a row. So I'm going to group it. So I have these 2 already. Now the left is another 2 here. Of course, it's going to be, it can be like this. Okay. I give you the drawing. Okay, let's say you can see over here, it's going to check below part. Oh, I have here. Upper, there is no. Left, there is no. Right is correct. So I have 1, 2, 3. Can I have 4? So I check over here. Oh, this one is cannot. If, let's say over here is 1, you can also draw like this. With this part and this part. If you get 1. But in this case, here is 0. That's why you cannot draw the 4 things. You go for only 2. You can have like this. Okay, you can have like this. But to minimize, you can see over here, you can just group like this. So why don't you just remove this one, because you already get 1 circle with this group. No need for you to circle 2 things 2 times, because you can see this one already in group. If you draw like this and you group again, this one has also 2 group. So what is the purpose having 2 group? But this one is needed. You can see. Although this one is in this square group and this rectangle group, it is needed because to help the others that is not in group. But if you already in group and this also in group and you're not going to help others for your circle, so no need for you to do the circle or grouping. So this is your final answer. So example number D. So for this example, you can go for by one. You can see over here, you look into your left, then you have here, okay, there is a possibilities. You go for upper, you can see, oh, there is a possibilities. So you have already 1, 2, 3. Check the things that can go for 4 or not, because you already have 1, 2, 3, and check another one, 4. It is 4. So you can have like this. Or then over here also. So that's why you can have a bigger group. It is 8 all together. Then what else you can group? You can group this one. And over here, of course, you need to group like this. Then done already. 1, 2, 3. For any question for this grouping, you need to do a lot of exercise. Then you will be familiar on drawing this. Okay. Determine minimum SOP and care maps. This one you will learn how to get the term, product term. Inside all the grouping, there will be a value for each other. But I think I'm not going to touch until that. I want you to do exercise for all this grouping thing. Because if you're still not yet familiar and you go for higher level, which is over here, you need to know what is basically inside. This one is EBA, what is this? And for this part, how you going to justify? So it's going to be harder for you. So it's better for you to finish and understand how to draw the care maps from your Boolean expression, if it is non-standard, and then how you're going to get the grouping. Then later in our next class, we're going to look into the Boolean expression. I think I'm going to also come out with extra videos for you to refer, because I think I'm afraid that we like a bit late from another section. Okay, any question? There is many other things to do.
So,
Yeah,
Doctor, will you give us more exercises later?
exercise question. Okay,
Okay.
I will try to find exercise for you. Maybe I'm going to pick from previous past year. Okay, any other question? So if there is no more question, please scan your QR code, and I think only that for today. Thank you for your participation, and sorry again for coming late because I got a meeting just now. Thank you, and meet you again next week. No, kan? I hope that for next week class, although it is your midterm break, I hope that you can look into your e-learning. I will share videos to your e-learning. Okay. So thank you and bye bye.
Thank you, doctor.
Okay.
Thank you, doctor.
Thank you, doctor.
Okay. Thank you, doctor.
Thank you, doctor.
Okay. Bye bye.
Doctor, when are we going to do the lab exercise though?
Lab 1 or lab 2?
Lab 2.
Lab 2, we need to finish first this module 4.
Okay.
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 Thank you.
Thank you, Doctor.
Okay. Bye bye.